Hey everyone, today we're doing 6.1 angles and their measures. So the first thing we need to know is a positive angle. You're going counterclockwise, so this way around your axis. A negative angle, you're starting from here. You're starting from here and you're going the other way around the axis. Standard position is the vertex is at the origin and the initial side is the positive x-axis. Quadrantal angles are when the terminal side lies on an x or y axis. So quadrantal is just like an angle like this. The angle is lying on that y-axis, and that is 90 degrees. So like 90 degrees is an example of a quadrantal angle. Okay, so for these, we're just going to be graphing them. We're going to draw each angle in their standard position. So 45 degrees. So we know that the first quadrant is 90 degrees. Half of 90 is 45. So we're going to split that about in half and say that this angle right here is 45 degrees. All right, for B, we're negative 90. So remember, if you're going negative, you're going in the opposite direction. Still that 90 degrees. So to here, and we'll just label that negative 90 degrees. Next, we have 225. And if we think, okay, 225, and we know that each quadrant then is 90 degrees. So 2 quadrants would be 180. 3 quadrants would be 270. So it's not going into the fourth one, so it's in our third quadrant. So how much into our third quadrant? So we can take 225 and subtract 180, and we get 45 degrees. So we know that if we go 45 degrees into that third quadrant and we go all the way around, that would then be 225 degrees. We can just label 225 degrees. Okay, next we have 405. So we know we said that 3 quadrants was 270. So let's add another 90. We get that's 360 all the way around. If we add another 90, we would get to 450. So that's too much. So we know 405 is between 360 and 450. So let's do 405 minus 360, because then we'll know how much above we need to go. 45 degrees. So we need to go 45 more degrees. Keep continuing that line. And that is 405 degrees. So you have to include that you circled all the way around and more. So that's 405 degrees. All right, next we're going to be converting minutes to rotations and rotations to seconds. So rotations is just like how many times you're like going around the unit circle basically. So one rotation is 360 degrees. 1 minute is, one rotation is 60 minutes, and then that 1 minute is 60 seconds. So we're going to convert first. We have 50 rotations, 6 minutes, and 21 seconds. We're going to convert that to a decimal in degrees. So we're going from rotations to degrees. So the 50 already is our rotations. So we have we already know 50 degrees. So we have 50 degrees, and then we have the 6 minutes. So we're gonna say 6 over 60, because it's 6 out of the 60. And then for 21, it's 21 over 3600, because we don't say it over 60 seconds because we're not going just from seconds. We also have to also include the minutes. And so if you think about it, the 60 seconds times the 60 minutes gives us that 360. So this then gives us 50 degrees. And then if you take 6 divided by 60, you get 0.01 degrees. And then you get 21 divided by 3,600 is plus 0.0058 degrees. Now you put it together, and that gives you 50.1058 degrees. All right, now we're going to go from degrees to minutes. So like rotations to minutes. So, and if you think of rotations, it's degrees because it's angles. So we're now going from degrees or rotations to minutes, time. So what we can think of first is we have that 21. The 21 stays. And then we have the 0.256. So then we can say plus 0.256. And if we want, before we divided by 60, so now we're going to multiply that decimal by 60. And this is going to start getting us those minutes first. So if you multiply that, you get still that 21 degrees and then plus 15.36 minutes. And then that's just minutes. And then it's 15 whole minutes and then 0.36 of that minute. So that's going to be in our seconds category. So we're going to multiply it again by another 60, that decimal point. So we have the 21 degrees, and then we have that whole 15 minutes, so plus 15 minutes. And then we're going to take the decimal, the 0.36, and multiply it by 60 so we can get seconds. We're in minutes from 15.36. We're going to multiply it by 60 to get seconds. And then this would give you still that 21 degrees plus 15 minutes, and then 0.36 times 60 is 22. So plus 22 seconds. That's it. All right, central angle. We learned a little bit about this back in geometry. So it's just remembering that formula. S equals R times theta. S is your arc length. R is your radius. Theta is that angle. So first we're finding the length of the arc of a circle with a radius of 2 and a central angle of 0.25 radians. So we have an R equals 2, and then theta equals 0.25. So we're just going to plug that into the formula. S equals 2 times 0.25, which equals 0.5 meters. Okay. Next, we're going to be looking at revolutions and changing degrees to radians and radians to degrees. So like how 90 equals pi over 2. 180 equals pi. We're going to look at like how you would convert that using math instead of just memorizing. So here we're going to convert the angle. So we have radians and we're going to degrees. So negative 3 pi over 4. And if we look at our rules to convert from radians to degrees, we're going to multiply the radian by 180 over pi. So times 180 over pi. Those pi's are going to cancel. Plug this into your calculator, and we're going to get that this equals negative 135 degrees. Okay, again, this time we have 3 radians, but we're still going from radians to degrees. So again, multiply by 180 over pi. So 3 times 180 over pi. It helps me just to have both as fractions, so I'm going to put the 3 over 1. And then now I have in here, we're not going to say like 3 times 180 divided by pi. We're actually going to plug in pi in the calculator and get a number. And this gives us 171.89 degrees. Okay, next is the area of a sector. I know this chapter is just a lot of formulas, so we gotta just keep going through and plugging in. So find the area of a circle. The radius is 2, so r equals 2. And then formed by an angle of 30 degrees. So theta equals 30 degrees. Okay, so when you're doing this, though, your theta has to be in radians. So first we need to change 30 degrees to radians. And how we do that is we're going to multiply now by pi over 180 because we're going from degrees to radians. So 30 times pi over 180 equals theta. So that whole thing equals theta. All right. So now let's just plug in what we have to our formula. So A equals 1/2. R is 2, so 2 squared times theta, which would be 30 pi over 180. Plug this in our calculator, and we will get that A equals 1.05. And then don't forget your units. This is feet, and since it's area, it's squared. All right, last part is linear and angular speed. So these are formulas as well, and you're gonna look at this. Usually will always tell you what to do. Your problem always will tell you what you're looking for, if you're looking for the linear speed or the angular speed. So linear speed only has one formula, v equals s over t, and v is your velocity, s is your distance, and t is your time. For angular speed, we have w equals theta over t, which is angle over time. And then we have v equals s over t. And if you go back to what s is, you can also say that s equals r times theta. So it's just multiple ways of writing these other formulas here, multiple ways of writing the same thing, but substituting different parts. So let's look at this example. A child is spinning a rock at the end of a rope of 2 feet, of a 2 feet rope at a revolution of 180 at 180 revolutions per minute. Find the linear speed of the rock when it's released. So we have an r of 2. We know the radius was 2 feet. And then we have the 180 revolutions per minute. So this is, and if we go 180 rev per min. Okay, let's look at revolutions per minute. What stands for revolutions per minute? That's W, because that's our angle over time. So this equals W. If we looked back up here, angle over time is W. Okay. Then we want to change, when you're finding your linear speed, because that's what we're looking for, you want it to be in radians. As we can look at linear speed, it's time and distance. So we want radians, not degrees. So we're going to change 180 revolutions per minute first to radians. So to change, we have 180 over revolution per minute, and we're going to multiply that by 2 pi over 1 rev, because 2 pi is what 1 revolution all the way around the unit circle is. So all the way around, that is 2 pi. So 1 revolution equals 2 pi. And that 2 pi is our radians. So if you put this in our calculator and we solve, we get that this equals 360 pi. And this is, radians per minute. Okay, now we can go and we can solve for our linear speed. So we have a V, we're looking for V, we have an R, and we have a W. So we're going to use this formula, V, R, and W. So we have V equals R times W, because that's just what we have. So that's the formula we're using. So if we plug this in, we get 2 feet times our 360 pi, and that's radians per minute, so rad per min. And then we get that this equals 2,262, and then that's feet per minute. And then this is asking us, we want to find it in miles per hour. So we are going to change this to miles per hour. And we get 25.7 miles per hour. Let me rewrite that. Miles per hour. All right, that's it. Let me know if you have any questions.